How's everybody today? Today we are going to be in 8.3 in your book. We're going to be solving right triangles. And the only thing we really need to talk about still is, well, we can find missing sides in right triangles, but today we need to be able to find missing angles. And the way we're going to do that is we're going to be given an, a ratio, basically, okay? We're going to be given a ratio. So if I'm given a ratio, I'm going to use the inverse in my calculator to find the actual measure of the angle. Okay, so here's how this works. You have a little conversation with your calculator. Okay, calculator's right there. You say, Mr. Calculator, if I have a right triangle and the sine ratio, the ratio of the opposite to the hypotenuse is 0.72 as a decimal, well, what is the angle measure? So you go in your calculator second, hit the sine button, and then put the ratio in and hit enter, and that's it. That's all you do. So you know that that angle, let's say that was angle A, is 46 to the nearest hundredth 0.05 degrees. Okay? All right, so now we can just practice that real quick. So if the tangent ratio is 2.38 to 1, so second tangent, 2.38. Go ahead, and that would mean you have a 67-degree angle. Oh, they said nearest degree here, so we can just round that. Cosine, try one of those. 73 degrees. So again, if the ratio is 0.29, then the angle is 73 degrees in a right triangle. Now, the sine, now this one is down number 4 down here. They're giving us this in a fraction form. No worries. Still the same idea. Those other decimals, it's the exact same idea. So second sine, go ahead and close it up. 7 divided by 16, which you could think of as a decimal. It's the same idea. Get 25.9, let's call that 26 degrees. Okay? Easy enough. Now that actual skill is very easy. What's going to be difficult for us is to decide, whether we want to use SOHCAHTOA or we want to use inverse sine. And the golden rule for you is if I want an angle, I should be using an inverse. And if you want a side, you're going to be using SOHCAHTOA. Okay? So let's go ahead and fill this guy in here. Let's go ahead and this right triangle, let's go ahead and make this big for a second so you can see it. Um, round lengths to the nearest hundredths and angles to the nearest degree. Okay? So first thing I'm going to find is angle B. Angle B should be easy to find because I've got 90 down at C, 42 here, and I know there's 180 degrees in a triangle, so this must be 48 degrees. Okay, now, side A, right here, circle him. Okay, it's a side, so I should be using some part of SOHCAHTOA, all right? So now we're playing, what do I have, what do I want, right? And I used angle A over here, and here's the reason I used angle A. If I made some sort of math error subtracting from 90, which hopefully we're not doing, I would have a mistake over here at angle B. So I want to use the angle that I know for sure is correct. So I make my labels from angle A. We call this the hypotenuse always. It's across from the right angle. This must be adjacent. This must be opposite. So the game of what do I have, what do I want, turns into, in this case, I've got the sine of 42, right? Opposite hypotenuse, O, so sine of 42 equals A, the opposite over the 9.8. Life is good. We just multiply that together, and I get 6.0 5/6, the nearest hundredth, right? Okay. Now, side B, I have two choices now. I could technically run Pythagorean theorem because this is 6.56. So 6.56 squared plus b squared equals the hypotenuse squared. The only problem with that is this is a rounded number right here, this a. We rounded that off. Even though we were pretty accurate, we went all the way to hundredths, it's still rounded. So when I square a rounded number, I'm basically amplifying any inaccuracy I have. So the most accurate way for us to find side B is to wander back here, go back in here and say, okay, might as well use that 42 again, and adjacent versus the hypotenuse. That's a ka. So adjacent hypotenuse is a ka, so CAH, so the cosine of, what is that, 42 degrees equals the adjacent, which I don't know, so I put in the B, over 9.8, the hypotenuse. Quick cross multiply, and you get 7.28. All right. So that time we decided we didn't have to use any inverses, okay? We didn't have to use any inverses. I'll go ahead and skip this one. We're going to practice number 6 in class. Number 7, now I'm only given two sides. So I've got to go ahead and find basically the angles. You got to find some angles, okay? So the first thing I'm going to do is I'm going to go to, again, it doesn't matter whether I pick A or B. In this case, I just happened to pick, which one did I go first? I went with A. All right, so angle A. All right, so angle A, now it's what do I have, what do I have? Let's make our labels. Here's the hypotenuse still. Here's the adjacent. Here's the opposite. All right, I have the opposite and the hypotenuse. So I say, hey, Mr. Calculator, opposite and hypotenuse make sine. So the sine inverse of angle A equals the opposite, which is 9.2. Let me move this down a little bit. The 9.2, the opposite, over the hypotenuse, 11.3. So then you go, okay, Mr. Calculator, I want angle A. Well, actually, this should be just sine to start. So I take the inverse of both sides. So this is just angle A over here equals the inverse. So you're saying to your calculator, hey, Mr. Calculator, if my ratio is 9.2 over 11.3, what angle does that correspond to? And your calculator obliges and says angle A is 50. If you do second inverse in your calculator, should get 54.5. I'm just going to leave it 54.5 this time because I worked it that way. All right, 54.5. Now angle B, we could subtract from 90, but two reasons. Again, I have a rounded number, so that's a little less accurate possibly, and we also want the practice. So let's go ahead and do the same thing for angle B. Now this is the adjacent, and this is the hypotenuse. So I have the adjacent, so the cosine of B equals the adjacent, 9.2, over the hypotenuse, 11.3. So now we do the same thing. Angle B equals, so now you're talking about angle B, and you're saying, hey, Mr. Calculator, if my cosine ratio for angle B is 9.2 over 11.3, what is the actual angle measure? And you say, punch it in the calculator, the second cosine, 9.2 divided by 11.3, and you get a total of 35.5. Yay, that works because 35.5 and 54.5 should add up to 90 degrees, and they do, right? Because the two acute angles add up to 90 degrees. Last thing we're going to do here is find side B. Okay, find side B, which is going to be back to, we could do Pythagorean theorem, but again, we kind of have we would have an unrounded or a rounded number that we're using in our calculation. So I used, excuse me, sorry, I used angle B in my calculation here and said, okay, um, actually, yes, I used angle B. And I said, okay, what do we have? What do we want? What do we have? What do we want? So opposite, okay, so the sine of angle B equals the opposite, which is unknown, the B, over the hypotenuse, which is 11.3. Okay, well, we know angle B, luckily, we know that that is 35.5. So the sine of 35.5 degrees equals B over 11.3. Do a quick cross multiplication, and we are all set. We get B equals, in this case, sine of 35.5 times 11.3 is a grand total to the 100th is 6.56. Okay? Now I've solved the right triangle. What does that mean? I have all the angles, all the sides for the right triangle. Okay, so that's your skill for today, solving right triangles. And the add-on thing that we needed was, given a ratio, I use the inverse to come out with an angle. Okay. All right, and that's what we're going to do today. Those other two examples that are in your packet, we're going to use those in class as quick checks, and hopefully everything is going well for you, and hope you have a great day. Thanks. Bye-bye.